Okay, so today I am going to be a radiation engineer for a manned mission to Mars. So recently there has been a lot of interest in a manned mission, a manned flight to Mars. The flight to Mars is 180 days, so it is a long flight, and with a long flight becomes a lot of radiation exposure. And so, because of the increase of interest in flight to Mars, there has also been an increased interest in the problem that radiation poses for a flight. So, what is radiation? Radiation is the energy that travels in the form of waves, which is electronic radiation, or particles, which is particulate radiation. On the electromagnetic spectrum, all the wavelength forms have radiation, but the higher the frequency, the higher the energy, and the more radiation and danger the form of light carries with it. Radio has one of the least, while gamma has the most. Gamma waves can kill living cells, and that's one of the reasons why they're used in cancer treatment. Gamma bursts are sudden, intense emissions of gamma magnetic radiation, but the sun is the biggest consistent contributor of gamma waves and radiation to our atmosphere. On Earth, natural background radiation is an everyday occurrence. It's not harmful, and we receive it every day. The average Americans will receive 360 millirems of radiation in their lifetime, and that's a pretty common dosage throughout the whole world. Some places it's higher and lower. But the atmosphere really protects us on Earth from a lot of the radiation that astronauts are exposed to in their missions in space. The typical radiation dosage in space is 1,500 millirems. So, the two types of radiation that astronauts face in space are the solar radiation and galactic cosmic rays. So solar radiation is the sun puts out in gamma rays. Solar flares are massive bursts of solar rays, gamma radiation. And galactic cosmic rays, this is a more long-term form of radiation caused by supernovas, gamma bursts, and faraway stars. It's less intense but more constant and really poses the greater difficulty just because of that consistency. So on a flight to Mars, astronauts in this 180 days would receive about 180 millirems per day of radiation. That's basically like getting a full-body CT scan every 5 days. So the amount of radiation that they receive increases greatly on their flight. But once they land on Mars, they would be receiving only 67 millirems per day. A lot of speculation is that the Mars dust, the regolith, decreases the amount of radiation that you receive on Mars. So really the main reason that scientists and astronauts are worried about the problem of radiation for astronauts is that radiation increases your risk of cancer. For astronauts simply spending time on the ISS, probability of getting cancer goes up by 5%, and cataracts become a very probable situation. Marie Curie actually got cataracts and died of radiation because of her prolonged exposure to radioactive materials when she was discovering the radioactive particle radium. So if we want to pursue a manned flight to Mars, there are some obvious problems that need to be addressed. Some solutions to the long period of time that astronauts are on the shuttle to Mars would be the techniques that come into play now are detection and prevention of radiation. So detection, scientists at NASA have been working on a new detector called the Advanced Neutron Spectrometer. It basically measures the neutrons in space by capturing them with a lithium isotope. And so one of these advanced neutron spectrometers on board would provide a measuring of the radiation that the astronauts are experiencing and provide a notification when they reach a critical radiation level. Prevention. There are a lot of things that you can do on Earth to prevent solar radiation and gamma radiation and long-term radiation in space. Based on solar flare predictions and the Earth's magnetic field, you could look at your launch time prior to launch and determine a time at which the solar activity would be low, so that the majority of your flight time would be in a period of low solar activity. The solar maximum is when the atmosphere of the sun increases, and with this increase in the atmosphere, the radiation has a harder time escaping the atmosphere, and so there's less radiation being emitted by the sun. And it's kind of like fish trying to swim upstream. There's a lot of force going against them, so it's harder for them to get upstream. So launching at the time of the solar maximum would provide a period of time that the astronauts in the space shuttle would not be exposed to as much radiation from the sun. The Lunar Reconnaissance Orbiter recently made a couple of orbits with a tool on board that measured the effect that plastic had on radiation, and it found that plastic greatly reduces the radiation dose from the galactic cosmic rays, the biggest contributor to dangerous radiation. So based on that discovery that plastic is a good preventer for radiation, outer suits could be made for astronauts to put on over their normal spacesuits that would slow the initial impact of radiation. Or you could increase the plastic content in the typical spacesuit. Right now, most spacecrafts are made of aluminum, which really was also found not to really do much against radiation. So some of the aluminum content could be decreased in spacecraft themselves and increased plastic content. So support from Earth. There are a lot of corporations and associations that can do a lot of prevention and detection for the astronauts on board. The NOAA monitors the space environment and provides mission control with invaluable data about space weather. And the Space Environment Center also does the same thing with predictions of solar flares. But recently the NOAA has a scientist that was working on predicting solar flares, and the scientist discovered that 2 to 3 days prior to a solar flare, the sun's surface beneath the atmosphere twists in a coil right before the release of the gamma rays. And they've already started to employ this technique in predicting solar flares, and they found that it's 2 to 3 times more accurate than the prior method. So if NOAA and NASA and the Space Environment Center were to employ this technique of solar flare prediction, the astronauts on board could be notified of potential solar flares in the duration of their space travel to Mars. And before the solar flare happened, they could be notified and put on their plastic outer suits so that the radiation from the solar flare would not be sudden, and it would not be as damaging because of their protective plastic suits. So The idea of a manned mission to Mars is like the next step. It's landing on the moon for our generation. It's a mission that holds a lot of hard work and goals for a lot of people, and there are really just a lot of things that we can do to prevent the radiation and detect it.